So first thing is that I used to be at IBM for more than I can count, more years than I can count. And I literally left October 31st after what amount to a lot of years, mainly because after all this time, you know, big companies, you get tired of it. Hopefully none of you get offended by me saying this. And also it's just AI is so much fun. There's so much going on that I want to be part of it. So new founder, that's why you see my badge has all things scratched up. But I go by Max, and during my time at IBM, just as an introduction, I worked on many different things. But during the pandemic, well, I'll say this. I did a Ph.D. in computer science 20 years ago, and it was on AI agents. And of course, when AI and agents started to become real again, like 2 or 3 years ago, after ChatGPT was released, it was an awakening, because a lot of the things that I was doing in my PhD, you had to imagine, now they were real. So I started getting involved in this. And of course, I'm a huge proponent of open source, so what I'm going to talk to you about today is completely open source under the MIT license, so you could actually go and use it, modify it. You don't have to tell me. Obviously, if you want to be part of the community, I'd welcome that. So that's kind of like a brief introduction. So let's get into it. There's a lot of demos and interaction. We'll do it all live, so hopefully everything works. But let me give you kind of like a quick introduction on the topic. So one of the things that you'll realize when you start wanting to build agents that do actually useful stuff for your domain is that you have to give them context on that domain. And of course, there's many ways to do this, but the interaction with agents right now is mostly through natural language. So some user, like when you use ChatGPT, you give it a question, and it has to come up with an answer for you. So how does it do this? So most of the way you actually give it context is through some kind of a semantic search. So you take the question and you do a search and you find documents or data that's related to the question or the prompt, and then you can feed that into the agent, right? So that's kind of what people are doing now, and you can do this through something called a vector database, and there are many different ones right now. The market is actually projected to grow to $10 billion in the next, I guess, 5 years. And I would say that a lot of the vector database that exists right now, they are very, they're in two camps. There's a camp of sort of quite native vector databases. So things like Milvus, Weaviate, they were built straight from the bottom up to be a vector database. But lots of other existing databases are essentially adding vector support. So you can, for instance, use Supabase, which is pretty much Postgres, and they have a vector support. MongoDB also has that now. And also even Redis has support for vector database. So vector databases, it's almost going to become, or it is becoming kind of the norm for all databases. And part of the reason is because of this growth of AI agents. And also things like RAG, where you do some kind of an agent that understands a set of documents that you give it, and when you ask it a question, it can actually use those documents to answer your question. So it understands, I guess it has its brain in the LLM, and then the data comes from the documents that you give it. And it's a very nice use case, but of course you want to make it as clear and as correct as possible. If you're dealing with a domain, let's say legal domain, and you want to have documents around that domain. If your domain is, let's say, retail, then, or like a retailer, which I'm working with, then you want the documents to come from that particular retailer, right? So that's where it becomes quite interesting to be able to build your vector database with documents that came from the domain that you're dealing with. Now, of course, the process of doing this, without going too much in the details, is that you have to take the documents, you break it into small pieces, so you chunk it, and then you embed the document. So what is that? It's basically creating, think of it as a collection or a vector of numbers on that document. So this embedding allows you, or these vectors that you're creating for each one of your chunk, allows you to essentially create a space. So now you have a space with all these vectors. So when somebody asks you a question, or like when the agent needs to find the documents that are most relevant to that vector, what they're doing is they're using techniques to essentially match a vector for the question or the prompt to the vector space. And then the idea would be the vector, your vector, and the vector of the document that's closest to your vector have a distance, and that distance either maximize or minimize, and you can use that to essentially find the vector that's closest to you. So there's tons of algorithm on this. The simplest one is to do cosine similarity, where you essentially compute the cosine of one vector to the other vector, and then use that number to tell you which one are the closest. But there's lots of improvements over that. So things like, for instance, trying to cluster the vectors so that you don't have to go and search the entire space. You can just find the centroid of the clusters, and then from that centroid, you only look through the vectors that are closest to that centroid. So there's tons of techniques. And the point of telling you all of this is not so much to give you kind of a lecture on this. Maybe you know better than me. But the idea is that there are many ways to essentially compute the similarity so that when you do a search, you get the best documents. And I don't think that's going to change too much, because there's not really one algorithm that's going to solve all those problems. And part of the issue is that human language is so complex that your query and the documents that you're trying to find from the query don't necessarily match perfectly, right? There's lots of context that you leave out, so it won't be able to necessarily find everything. However, if you cluster, for instance, you may be able to find the documents 2 or 3 levels deep, or you may be able to find other documents that are related and then find future on. So for instance, things like graph database allows you to sort of infer what the data should have been, right? So the point here is to say that there's many different ways to essentially search that vector space and build it as well. So it's not just searching it, it's also being able to build it so that when you search, you're efficient. Because obviously if you did a query and it took 5 minutes to get a result, even if the result is perfect, that's not useful, right? So it has to also be fast. So what people start doing now is you do a little bit of a hybrid solution. So you not only do a semantic search, which is what the vector search is, but you also do like BM25 search, which is really well known in the industry. And if you have enough terms, you can actually find very precisely the document that's being, that would be important for that result. So when you start doing those hybrid search, you get better results. Okay, so that's cool. But you now have to build those hybrid search, right? So in addition to assuming that you're doing the right search, there's also the fact that you have to prepare your data correctly so that you can do those searches. So it's the embedding, it's the chunking of the data, it's dealing with, let's say, multimodal data, because let's say you have a PDF, it might have images in it, it might have table. So how do you deal with those different types of data? So that's also kind of another of those kind of foundational issues. So what I built, and this is what we're going to talk about, so the rest of the talk is going to be hands-on demo, came out of building a bunch of RAG solution inside IBM and dealing with the variety of different documents that I had to deal with. So the last year I spent working in the quantum division of IBM. Even though I'm not a quantum scientist, I was part of that team. And the data, of course, with quantum is very specific around not only quantum physics, but also computing and programming and so on. And you start realizing that the basic solution for RAG doesn't necessarily work. Or at least it works, but it doesn't give you the optimal solution. So you start discovering that you need to explore different ways of embedding, different ways of chunking, so that, for instance, when you have a long piece of document, when you chunk, the situation could be that you divide, let's say, by 10, so you now have 10 chunks of the document, but the reality is that you're not gonna find a perfect overlap for each one of those 10 documents. And the context from one document kind of spills over to the next one, or it maybe is like 3 levels down. So how do you deal with all that, right? So the chunking algorithm becomes important, and as well as the search, right? So all of that kind of led me to the realization that I needed a way to explore many different vector databases as they were coming up, many different algorithms, and different types of chunking and different types of embedding. So that's kind of the basic problem that I had. And then the last thing is, as I realized, part of the problem is this constant processing of the data and constant testing and so on. That, and I hope I don't offend anybody, but I've programmed in every language, but Python is the slowest I programmed in. And, okay, I lost the screen. So, yeah, there we go. So I needed a way to be able to do this fast, right? Like process documents all the time, searching them, testing, and so on in a very fast pipeline. And the Python tools that I was using were just horrible. So I built this thing called Weave-CLI. So let me first show you the where you can go and check it out. And I'd love for you to give me a star. This is about a month old, so it's relatively new. But you can see lots of activities because I've been sort of thinking about this for a long time. It's under the MIT license. Everything's there. We've had already 5 releases. I'm pretty much the only contributor. I definitely use AI, and it's written in Go, and that has a lot to do with why it's so fast, okay? And we have many databases supported already, and we'll talk about some of this, so let me just get into the demo. Okay, so it's a CLI, so you can just do Weave-H, and you can see the different collection of groups of commands. So you can do collection management, document management, configuration, and then embeddings. So first thing you do is you have to configure it. I already configured it for a set of databases, so let's look at what I have. So you can say weave config list, and it will tell you the databases that you have configured, and you can see I have Weaviate Cloud. So this is, Weaviate is open source, but you can use Weaviate, the company, which can host your database. So obviously, every one of those databases have a similar notion, where you can have it locally, or you can have it in the cloud. Milvus is also one of those native vector databases, and I have it locally here. And then Supabase is not a vector database. It's just a regular relational database, but it's one of those databases that has been catching fire because they make the process of using it very, very easy. It's well understood because it's a relational database. It's based on Postgres, so it's pretty decent and good and fast. And it's also super cheap to start with. So that's one of the advantages of, I mean, the other ones are cheap too, but in terms of, if you had existing database that you were using, you can migrate to Supabase pretty easily. But they also added vector support with PG Vector, which is an extension of Postgres. Anyways, so I have all 3 of these. So what can you do? And we'll go back to configuration because obviously to get started, you have to configure things. So I can tell you the details for that after. So assuming you have those databases configured, what else? What can you do? So the way vector database works is you create, and most of them follow the same concept. You create a collection. So it's kind of like a bucket. And then you add documents to that bucket, chunking it, embedding, and then you can now query. Okay, so it's very straightforward process. Obviously, if you can add stuff, you can modify, you can delete, and so on. Okay, so first thing we'll do is we'll say weave collections list. So when you do that, Weave-CLI will essentially find all collection from your different databases. And you can see here it found 30 from Weaviate Cloud because that's kind of the database I've been using the longest. And then you can see it found local, and you can see it tells you which embedding was used for that collection. So of course, then what are the embeddings? You can say Weave embeds. And of course, like everything else, you can say -h, and then it tells you the different, options. So in this case, we'll say Weave embeds list, and we can say, I think there's a way for you to tell it what are the compatibility. So let's see if I can find it. Hold on. Embeds. Hold on. And then I think it's compatibility. Embed. Hold on. List. And then you can say show compatibility. And that will tell you the compatibility for the list. So for instance, you can see here that these embeddings that are supported by basically OpenAI support, it's probably one of the most compatible embedding. And obviously the embedding is converting your data into a vector, and not all data look the same, so you want to figure out what data you have and what embedding you should be using. There's a default for each one, of the databases, but that's something to explore. Another thing that's important is to notice that this is an OpenAI embedding. So what does that mean? Well, it means it came from OpenAI, and it requires you to have an OpenAI key to use it. So they have not made that public. But there's a huge number of public embeddings, algorithms that you can use. Like Hugging Face has a few, AWS, and so on. And the notion here is to be aware that it exists. Hopefully your data is not so specialized that default embeddings don't work. But if you start seeing that the results are not good, then the first thing to do is to start looking, oh, could I explore with a different embedding? Okay, so showed you the list, and I will keep going as we add more database to it. What can you do next? So next thing you can do is you can, for instance, see the documents in your database, right? Or in your collection. So first let's look at the collections again, and you'll see that in Weaviate and Supabase, I have a Weave docs. So this is basically a little test collection that I use. And you can see I use the default embedding, and I think for Supabase is OpenAI that I use, like text to vector, okay? So with that, I can now list the documents inside that, right? So I can say docs, let's list to ls, and then say, for instance, you can list things on one database, or it can try to find all that collection in different database, so I will tell it, right? So we'll tell it that we want Supabase. So basically, list all the documents in the collection called Weave docs, but only on my Supabase configuration. And this is live, so it goes and it finds them. And you can see the documents show you the content and then also the metadata. And you can see there's like 18 content. Why is that? Well, because there's 8, it's basically chunked it, right? It chunked the document. But that's kind of nice, but it's not very friendly, because you don't know, right? Like let's say there was 1,000 chunks. Where did they came from? So what you can do is you can do -- virtual. So create a virtualize for me response, and then -s or -- summary to summarize it. So what that's going to do is it's going to go through your chunks, and it's going to group them and tells you that I have a README, user guide, and right. So for instance, I can add a new one, new document, so you can see. So I have a to-dos here, right? So let's add that. So you can say weave docs create, and then we're going to pass it in weave docs, and then of course we're going to put the to-dos. To-do. And then I want to add it to Superbase. And I'm going to accept the default chunking and default embedding. But if you wanted to change those, -- specify. So what it's doing here is going to take that document. It's going to chunk it into 2, because I think the default is like 500 characters, or 5,000, sorry, characters. And then add it. So now if we list it again, right, it should add that to-dos. Cool. All right, so what else can you do? Because remember, you can deal with different databases, and I have the same collection in many databases, so I can just say Weaviate here, and you can see it will get me the collection in Weaviate. And you can see Weaviate has different documents in it. But what else could you do? You can query. So you can do something like, so the query is by collection, so you say calls, Q, and then you pass it the name of the database, the collection, sorry, and then you give it a string. And that string can be one word, but it could also be a complete sentence. And it's going to search it. And what's cool is that it doesn't just search and tell you what the documents are, it gives you a score. And you can see that all of these are related to a document that I have that is a Leica document, like my camera, like Alexi was saying also, we're a huge fan of Leicas. So of course, this is kind of nice, but if you were using this in, let's say, in an agent, you want the data in a way that you can process it. So what you can do is you can say --JSON, and it will return JSON version. So now you can parse that JSON and do some fancy stuff with it, right? And you can see it gives you the scores and so on. But when you do it without the JSON, it gives you additional information. Like for instance, you can see that because you're doing a vector search, the scores are not going to be like 1.0, right? So anything that's usually higher than, like lower than 0.3 is usually that it doesn't find any search. But anything bigger than 0.5 is usually a decent match. Of course, we could do more searches and try, but let me show you more features. Another thing you can do, and you know, obviously Weave is flexible to work with different databases, as I mentioned, and you can see that the process of dealing with all those databases is the same. So I'm kind of unifying all those databases, right? And that's kind of cool, but you need to learn it, right? Like anything else, I built an MCP around it. So now we have an MCP server for all the commands so that you can now have agents call Weave. So I thought, okay, but that's kind of cool. But what could we do to help humans, not just agents, is to say, okay, well, what you could do is instead of knowing that to list a collection, you have to say calls, ls, you could just query, right? So what that does is it goes to a collection of agents that I have in Weave-CLI, and it creates a plan to essentially execute, and even some scripts, and it will go through the process of creating, you know, giving you an answer. And the question can be pretty complex. I'm using OpenAI in here, and I think it's GPT 4.0, but you can change it to Claude. You just have to also include your API key, obviously. And you can see I also included metrics because I was working with the guys from OPIC in a hackathon to tell you how much it cost you. And you can see here it's like 1 cent. And most of the questions are about 1 cent. They're pretty cheap because they're not going like thousands and thousands of tokens. They're like 5,000 tokens, so it's about that price. And then I also figured, well, if you're gonna help humans, you should give them tips and recommendations. So obviously I need to format this a little bit better, but the idea is that I give you kind of anticipate what the next step is gonna be, what the recommendations are. I tell you all the details of, you know, how long it took you, and of course your answer. And of course, I was thinking, well, that's kind of cool because people can now query at the natural language. But then I remembered a lot of what I'm doing right now. I mean, I started using Cursor like a year and a half ago, and then gradually realized, you know, I just need a CLI. So I love Claude and all the different CLIs that exist, like AMP, and I think Amazon has one out called Kilo, and I think Google has one also. So I was like, I'll build my own. So if you call Weave without anything, it's in interaction mode. So in this mode, you can actually start asking a question just like you would do with Claude, and it will respond. So for instance, we had the question of listing the collections, but you can say, hey, show me the collections that are empty. So it's gonna be a little bit more complex query because it not only has to find the collection, but it also has to find the ones that are empty. And of course, you can do more complex things, and it will actually ask you, you give me permission, just like Claude, right? Like, so for instance, if you tell it, go find documents in this directory and add them to this collection, like a complex query like this, it will actually do it, but it will ask you for permission and so on. And you can see it's going through all the collections and finding the ones that are empty and listing them. And then you can ask it more questions. So it's a complete solution for you to deal with your vector database in a fashion that is, I guess you could say, uniform, but also, I hope you appreciate, it's also quite fast. I think before doing this, I had a series of Python script for my databases, and again, not hating on Python, but this was 100 times faster than Python. Now, obviously, for some queries, it'll be different. And I think part of the reason is because you have to load the entire Python environment every single time, right? It takes quite a bit. Whereas here, it's Go and it's super fast. I mean, there's a reason Go exists, okay? So if you haven't looked into Go or Rust, these are typed language, they're compiled. You have one binary, so it's basically Weave, and let's say, and it's like 60 meg, right? And that includes everything, including OpenAI agents. I think I have like 6 agents because I have one to understand a query. Because like if you ask it a question that is not vector database, it will say, I don't know. Like it's not only gonna answer a question on vector database. So with that, I have 30 seconds left. Let me stop and see if you have questions or if you want me to explore more. I'm happy to answer as many questions.
Thank you so much for that wonderful talk. And yeah, we're opening it up for questions. I'll just bring you the mic over.
And of course, connect with me. I'll put this, and then I'll switch to the command line if there's any questions. So let me put my QR code. So this is the project, and then this is my LinkedIn. I'd love to connect with you, so just send me a connection on LinkedIn, and then of course, you know, go to the project and give it a star. I would really appreciate it. So with that.
Thank you for the talk. I think there's a absolutely need to make the approach and use of vector database easier. Whoever can make it easier, the better. But from my own experience, after the chunking and figuring out how to overlap, most of the people who want to do this are, at least from my experience, have been the RAG crew. At a very specific, just like you said about quantum computing, they're very, very specific. And more than anything else, it's that domain jargon that seems to trip things up. So switching between different embedding coders between OpenAI and AWS didn't do very much. What ended up happening is that if I can get enough document, it was better to just cook one up using Expert, right? So then you have an encoder that's very, very specific to the document you're trying to deal with.
Right.
So
I don't support that yet to add your own vector embedding, but you know.
No, I
that's
mean,
something
it'd be
to explore.
even better if you could actually cook one for us, right?
Oh, like automatically understand.
Automatically generate an expert for us, right? Because it's so specific to that jargon.
I'm not gonna say it's impossible because.
No,
we
but
have AI,
that's the first thing.
Yeah,
And God knows I completely agree with your statement about the slowness of Python, right? I think because he went so broad,
Yeah.
nobody gave too much thought about the optimization. So most of us who don't want to mix and match languages, we
Yeah.
try to do the most heavy lifting with GPU optimization, right? So from personal experience, and I don't work for Milvis, but that's the only company that I know that, you know, because the nature of the vector, you can do so much things faster if you can get GPU startups,
Yeah.
right? So, you know, I think Python is just shoveling stuff around. So
Yeah.
now even like a lot of the data you're talking about, pandas, all that stuff can be run on GPU. So it seems to make a huge world of difference if you minimize the number of data touches. So that would help a lot. And last but not least, back to the RAG, it's not so much the work, it's the document curation.
Yeah.
You want to try to answer a specific question, and it doesn't really do a good job of figuring out what's the most important document. So you end up having these bundles of document that you created that you're going to use to do certain RAG boosts. So the other thing that might be really, really helpful is that if we can help automate that curation. So if you only know ahead of time, you're going to have N different types of Q&A you're going to support. If you can not only properly classify, but as the new information comes up, which is the number one reason why you want to run RAG in the first place, that kind of like curation can also be automated. You know?
Yeah. No, excellent points. I'll definitely, I mean, first is join the community. It's open source, right? So if you feel free to start a discussion on these things. I think with AI, I wouldn't be surprised, for instance, what the first suggestion you had about, you know, could I just in Weave-CLI, if you use it to do all your documents and to do a bunch of queries, try to figure out the best embedding, for instance. I think that's totally possible. I mean, we could probably explore that.
Sorry, Joe, we need to start preparing for the next speaker. Thank you so much.
We can talk after, definitely. Any last question? One more, since anybody else? No?
All right. Thank you so much, everyone. Thank you so much, Max. All right. Let's prepare for next speaker.